Hello, guys. Thanks for joining us today. Today we'll be speaking about NoSQL databases. These are great technologies that can be used and actually are used on many different projects. So I will soon pass a word to my colleague, but I just want to remind you that you can ask all questions that you have in our YouTube comments. We will answer them all. And that's probably it what I wanted to say. And I'm happy to present my colleague and friend, Rodion. Passing word to you.
Yeah. Hi, guys. As Daniela said, we have a NoSQL introduction today. So I think we can start. Let's go. So a few words about me. My name is Rodion, and I'm software engineer at EPAM Systems with 3.5 years of production experience. So let's speak. What is scaling? Scaling is just the situation when you need to add some resources and improve performance. And sometimes when your application becomes popular, you need to handle more requests. And there are different types of scaling. First of all, it's vertical, just simply give more resources to your database or other server, but it has drawbacks like cost, because it's kind of expensive. You cannot extend your resources infinitely. And the second option is horizontal scaling. It's just an adding of new servers. As a pros, it provides us infinite scaling, so you can add them as much as you need, and even server breaks down, other services can handle these requests. But the drawback is that you need to load balance between requests between all of them. And of course, horizontal scaling is considered as a best practice because it provides us infinite scaling. So as we know, relational databases have some limitations. First of all, it's scalability. You cannot just really scale it horizontally. Next one is performance, because normalized data requires many joins in case of hard and complex data structures, and exit transactions have a huge overhead. Also cost, because when you need high performance and a lot of scaling, it costs a lot of money. And next one and last one is a strict schema. It can be both as a benefit and as a drawback, but because it's reliable, but it's difficult to change it in production. Next one is the difference between NoSQL and relational databases. So what is NoSQL? NoSQL is like a not SQL or not only SQL. There are like two definitions. Not SQL is like don't support SQL standard. Not only SQL is like they have structured query language, but their own. So yeah, and now let's discuss the differences between SQL and NoSQL databases. First of all, schema. In relational databases, the schema is fixed and it's hard to change. You need to do migrations, you need to update the tables, create new columns. While in NoSQL databases, it's dynamic, or even there are no schema at all. In relational databases, data structure is table based, and we have a relationship between these tables. In NoSQL, we have different data structures, and this really depends on the database. There are such databases: document-oriented, graph databases, key-value databases. We'll discuss them later. Scaling. So regarding relational databases, scaling is primarily vertical, and it's expensive, as we discussed before. While NoSQL databases provide us huge amount of so yeah, that's scalable because it's both horizontal and vertical. And we can create a huge amount of clusters of these instances of DBs. Regarding data access, while relational databases use joins, NoSQL uses denormalization. So data is structured in a denormalized way. And transaction models. So let's discuss them a little bit more. So let's compare them, exit and base. What is exit? Exit is like more about data consistency and data availability. So it provides a consistent system to the data, that it won't be lost. Operations won't be completed partially, and you can't lose financial data when the server's down, as your application just won't commit it won't execute a commit in case of DB fail, and your system will be consistent in any moment of the time. While base provides us high availability, if one server's cluster breaks down, we just replace it with another. So base is like an acronym for this: basically available, soft state, and eventually consistent. Basically available is that data should be available even if it's not consistent, or there is one more meaning, that database server should respond even with exception. Soft state, yeah, that's about due to lack of immediate consistency, data values may change over time. So, and eventually consistent, that after all this, the stuff that happens with our data, data will be consistent eventually. Until this, the data can be different in different clusters or different instances of the database server. Let's compare sharding and replication. Sharding is basically horizontal scaling. Data is distributed between several nodes, and each specifies a specific subset of data. We need to load balance the requests between such shards. Replication is the copy of the data, and also replicas can be used for read-only purposes if the main server doesn't work. So as an example, user writes data to the DB. We replicate this data to replica, and we read it from the main database. In case master falls down, user can now this becomes the master database instead of replica, or a user can read it as read only. So yeah, which are the main NoSQL data types? MongoDB is document database which stores documents usually in JSON format. Inside of it is like a BSON binary JSON, but for us it looks like a JSON. Redis is a simple, super fast database of key value type. That's some kind of map string in Java. And Neo4j is a graph database, stores objects and their relations. That's demo time. Danila, maybe there are some questions in the chat.
No, unfortunately, I don't see any questions, guys. If you have them, you can ask them. Let's
Feel
proceed
free.
with the demo. We'll try to answer them a bit later.
Okay, so let's proceed to the demo first. One is Mongo. So we've already installed Docker. We've already installed Mongo and run it via Docker. So guys, if you want to know how to run something via Docker, in future, in like few weeks, we will have the talk about it. So yeah, don't forget to join. For now, I just ran it and started MongoDB Compass. That's an application for managing of Mongo database. So I connected to the database, and now I'm going to create the collection. That's some kind of a table where we can store the data. So I've already created a new one and exported the data from JSON file. I imported it from file, and now I'm going to show you this file. That's it, how it looks like. A lot of JSON's objects here. So how can we query these files, and how can we manage them? So the MongoDB has its own language for querying data. Now I'm gonna write simple filter. So here we have an object, and I'm gonna look for objects that have status publish. I'm gonna create such structure. It looks like the JSON file. So here we have status, and value publish. We are finding an object, and the result is here. Let's try to find something that doesn't exist. Oh, no results. Okay. So this way we can filter the data. Also, we can use aggregations. Aggregations is like a set of operations that we perform on our document, and we can do it in a sequence and then get the result. It doesn't affect main document and all these objects that were here. So these objects are not affected. Let's manage the data. So okay, let's create the pipeline where we find the object with status publish. That's a match here. Okay, and the status is publish. Yeah, we already have the preview of 10 objects, which that's 10 objects where the status is publish. Then we add new stage. Let's add the field. Add field here, and we have an expression, new field name. As we can see here, we have an authors. Each array has its own amount of authors. Let's add a new field which is called authors count. with value that will be the count of objects in array. We can do it via this way. We describe the size, and the amount will be authors. Authors count, add field, size, authors. No preview, strange. Sorry.
I think you.
Yeah. Oh. My mind lagged a little bit. So yeah, now we have a new field on the object, which is author count, and it depends on the amount of objects in these authors. Now let's add a new stage and filter the object which have authors amount about 3. That's again a match. We type authors amount, and value is just to copy and paste. Let's pick the values that are greater than 2. We can describe it this way. GT, which is like greater than, and 2. So as a result, we have an object which have like 2, 3, 4. Yeah. And as a result, as a final stage of this pipeline, let's count all these objects that are left after all these transformations and filters. Let's name this as a total. Okay, and we can run it, and we can see that we have the total amount of such object is 66. In document, we can still run the publish, and as we can see that no additional field authors count were added. So that's kind of read-only pipeline. It doesn't affect our data. Okay. Danila, maybe new questions appeared?
Yeah, actually, we have several questions. The first one, you mentioned few NoSQL databases. What is the main difference between them? For example, Apache Cassandra, MongoDB, and DynamoDB. I think we should better cover this question in the end of our light talk. Maybe it would be easier to understand. So, Aaron, for now, we will skip this question, but we will definitely return to it. The second question was, what is better, ACID or base? And do all NoSQL databases provide only base guarantees?
Okay, so there is no like silver bullet for this. It depends on your situation and your requirements that you need. If you need like the very strong atomicity, so when you work with financial data and you don't want to one of your transaction is lost or partially added, then yeah, you have to use or you have to use SQL and ACID databases. While NoSQL databases provide you more about scalability, and it's not expensive as for ACID databases. Yeah, Daniel, you wanted to say something?
Yeah, also ACID guarantees require very huge overhead over data computation. So base databases are usually faster because they just don't have this overhead. So if performance is more important for you than consistency, maybe base databases are better for you.
Yeah, and don't forget that you can use both databases at the same time. For example, for money transactions, you can have like ACID databases, while for some user data or I don't know, some I don't know, list of items in your shop. It can be base. So yeah, and regarding the consistency, if we are talking about ACID, serializable is, as Danilo said, rather overhead, and these data computations are really expensive.
Yeah, there was the second part of this question. Do all NoSQL databases provide only base guarantees?
It depends on the database. For example, so actually we have a CAP theorem. Let's dive a little bit into it. We have the capacity is consistency, availability, and partitioning. And system at the same time can't support 3 of them, only 2 of them. So it depends on the database which of them to choose. So I think that's the answer.
Yeah, I wrote the name of this theorem to the chat if you want to read more about it. Yeah, I think I can add a bit more on this question. Some NoSQL databases provide ACID guarantees, but definitely not all of them. Usually, graph databases tend to have ACID transactions. So, for example, we will have a demo on Neo4j database. And as far as I know, it has ACID transactions. But, for example, Redis does not have, and it will never have it.
Yeah.
Yeah. You
So
wanted to add
let's
something?
move. I think no.
Yeah, we have one more question right now. Could you name other popular NoSQL databases which can be used not only with powerful Java frameworks?
So as an example, we have Redis, which is a NoSQL database, and we will have a demo in like 2 minutes. How to work with it.
I would say that all popular NoSQL databases can be used not only with Java, just we are Java community school, so we're given some Java perspective. But definitely Mongo, Redis, Neo4j, all the cloud databases like Cosmos DB or DynamoDB or Cassandra that were mentioned in our chats, they can be used with any popular language. Basically, you can select any kinds of NoSQL database that you want if you use a popular language, not just Pascal EBC.
Yeah, database companies are interested in providing such API for different languages. For example, I don't know, the most popular is like C#, .NET Platform, this stuff. And developers are interested because they are not limited only for specific language servers. Of course, there are some languages like Pascal ABC that are not applicable for database management and database work, but yeah, for the most popular languages, this API is provided.
Yeah, let's move forward, but I will just remind you guys to subscribe to our channel and put likes under our stream. It really helps us. Thank you.
Okay, guys. Let's move forward to the next demo session. We have the Redis. Here, I've already run it via Docker again. I've connected it locally via CMD. And what is Redis? Redis is a key value database, reminding it. And we will have a simple example how to work with it. So this API is pretty simple. So let's set a new value in it. We can write set, and it already helps us a little bit. We need to add some key and value. Let's add key school and value MJC. The result of operation is successful. Get school. Okay, that's MJC. Let's delete this school. Unfortunately, there is no value by key school. as we deleted it. Let's add some value again. Let's make it the key job and the value is programming. Okay, we have a job programming, and let's add the expire for this key. What is it? We add the value of seconds after which this value will be expired. So let's see how much time left. It's via TTL common TTL word. As we can see, seconds are decreasing, and when we get the job now, there is no job because 20 seconds left. Also, we can have the not only simple data structures as the values here, but also such structures as lists and queues and so on. Let's create the key, name it, I don't know, collection or list better, and push element there. Let it be Spotify. And let's check how much elements are there. To check the elements, we should name the user L range, then key, and start and stop. That's like then indexes for our list. Let's start from 0 and stop. If we type 1, it will be 1. If 2, it will be again. But if we want all of the objects, we use -1. Let's add one more element to this collection and check them all. So 0, 0. Okay. It adds to the start of the list, as we can see. So I think that's it. Pretty simple demo to the Redis, and we can move forward.
Yeah, actually, we have one question on the Redis. Why use Redis instead of just using MongoDB? Aren't we getting pretty much similar functionality?
Okay. So Redis provides us like a key value storage for us, and it's pretty convenient when we want to use caches in our services. So, for example, you can have such mappings like ID to ID in your services, and it's kind of lightweight because. Yeah, it is. While MongoDB API is rather complex and it stores objects as a binary JSONs.
Yeah, from the usage perspective, MongoDB is a great choice, but it's much slower than Redis. From my personal experience, Redis can provide sub-millisecond responses. So it's like 800 microseconds. It's extremely fast. Actually, Redis doesn't provide the same functionality as Mongo. Mongo has much more comments and you can build really complex pipelines with it. But if you don't really need them, if you need just to set key and get key, Redis is the fastest database that you can use nowadays. And
yeah.
The next question from the same person, isn't Mongo lightweight also?
I wouldn't say that the Mongo is a lightweight database. I think that it's more lightweight than Microsoft SQL service, as an example, but that's not as lightweight as Redis or other in-memory databases.
Yeah, so compiled Redis is like 6 MB, I think. It's really small and really fast. Mongo is fast, but it's can be 5 or 10 times slower, which is usually okay, but not in all cases.
Yeah,
Okay.
in case of performance, when you need to have some optimizations and caching, think about Redis.
So reading data from Redis is much preferred. Yeah, I would say that if you have a Redis database, you should read from the Redis database. But Redis has very few, well, it has much less functionality than Mongo or SQL databases, so you just cannot use it in all cases. Redis, for example, doesn't have joins. You cannot join two keys together. If you do need joins, so you just cannot use Redis. But if you don't need them, Redis may be a good choice. Also, Redis is an in-memory database. So if something happens to your server, for example, it restarts. It's a pretty usual operation for a server. If the server restarts, then all the data is lost. So Redis does not save it to the disk to improve the performance. If you are okay with losing all the data, you should probably use Redis. Yeah. For example, if you have a cache, so you read data from the SQL store, you spend a lot of time to read this data, and then you save it to Redis. And you can read it from Redis very fast. Here, if you lose all the data from Redis, you can just read it again from the SQL database. In that case, I think Redis is a really good choice.
Yeah, that's a nice highlight because, yeah, that's very important that Redis doesn't have its volume, while in Mongo and other databases that allocate disk storage, they haven't saved it. So that's why the Redis uses for caches or some in-memory calculations in most cases.
Yeah, let's go further. Maybe we can answer all other questions later.
Okay. Let's move forward. Let's speak about graphs. So what is a graph? Graph is a, oh, sorry. Something happened. Graphs is a mathematical object that describes some entities. So here we have entities, that's vertices, A, B, C, like, or 1, 2, 3, 4. And their relations, edges. Edges is like an arrows. Graph can represent anything. Yeah, as mentioned, social networks, railways. So, for example, you and your kids, their kids, such stuff. And graphs can be both directed and undirected. So, as we can see here, there is no arrow because while here we have arrow. What is a relation? So, for example, when you describe kids, you can the arrow describes who is the parent and who is a kid, while when you describe the, I don't know, railway stations or cities, there is no need to arrow because the road is like both directional. But let's move to the demo and let's try to use Neo4j. It's a graph-oriented database. So here we have installed Neo4j, and it provides us some tooltips how to work with it. Let's check that we have any data. To check it, we should use match, check entities, and return them. For now, no entities were found and no records. But Neo4j provides us default data, like example data. We can check it right here. Oops. Ads, basic queries, example graphs, and let's use this one, movie graph. So it creates some graph. Let's add it. It creates it. Yeah. So here we have the graph. It's directional graph with the movies and actors and directors of these movies who participated in the creation. So, for example, we do have the Green Mile movie, and we can see that Frank Darabont directed this movie. So these are the entities, and these are the directions of the graph. So that's a directional graph, and we can see that, yeah, he is directed this movie, and Tom Hanks acted in this movie. And we can use a relationship between the entities in a graph via the directions. So let's write some queries to this stuff. I'll close all the windows that Neo4j opened for us. Let's again query all the entities. Yeah, as we can see, the same data returned, and we can see the nodes here, which are the entities, and different relationship types between the nodes, like directed, acted in, produced. So this graph is pretty big. Okay, now let's query the node Tom Hanks. Match, that's like a select for us. We name the Tom, and we describe the properties of this node. We know that it has a name, and its name is Tom Hanks. And what we should return is return Tom. This one. Oh, I'll use it here because it will create new window. Yeah, so we just found the node, and it's in case we click it, we can see the basic data for it, like its ID, born time, etc. And we can see the data in a table. I don't know why it's table. It's more about JSON than a table view. Okay, let's make a little bit complex query, and let's find the node Tom Hanks and the movie where he acted in. So we can use again Tom Hanks match, and then we can describe relationship. We can write this minus, then type of relationship, as we can see, acted in, and then we describe the name of the node of the nodes, and then node type and return value. Okay, as we can see here, we have the Tom Hanks node and the nodes where he acted in. And we can see the relationship between them. Also, we can see that as we fetched the the nodes that there were where he acted in, we can also see other relationship that also Tom Hanks directed this movie. Okay, let's write a little bit more complex query. So let's find the person which is actor Kevin Bacon, who acted in movies. And let's query the directors of this movie as well. We describe again this relationship via minus director, type of relationship here, director, and then the person. Director, person. And return what we need is like, oh, it shouldn't be Tom. It must be Bacon, movie and director. Bacon, movie and director. Oh, it highlights something. Directed, wrong. Directed. Okay, so as we can see, Kevin Bacon acted in 3 movies, and 2 of them were directed by Rob Howard, and 1 of them was directed by Rob Reiner. It looks like Kevin Bacon acted in films of the guys who start from R or even row. That's it. In case you want to delete all the nodes in your application or in your database, you have to write something like this. Match n, that's like everything. That's like the name of the variable. We don't describe any filters here, so we just name this as n, and detach delete n will delete all these nodes n. Yeah, and we can see that 171 nodes and such relationship were deleted. Okay, Danila, maybe a few questions regarding Neo4j.
By now, no questions about it, and there are 2 more questions about previous demos, so I think we should answer them a bit later.
Okay. Okay. Let's move forward. So there are also other NoSQL data types. We described 3 of them and demo them. Now let's speak a little bit about other. So Cassandra, as a question from the chat, that's a database of a type white column used in most cases for big data, and it can store like the thousands and hundreds of petabytes of data, and yeah, it's most used for big data, data analytics, and such stuff. I had experience with working with BigQuery of Google, and the API of it was SQL-like because it's like a big table. Yeah, and as it mentioned here, each row can contain thousands of cells. Let's move forward. Next one is full text search engines, as Elasticsearch an example. So that's used for searching of documents, text, and such stuff in the web. For example, when you have a big library of documents and you have to find something in one of them, such databases will be very useful. And the last one is time series databases. It's for it's databases where it stores data, timestamp, and then value. It's like a key value where key is data timestamp. It's used, for example, for some graphics, for some metrics, where we can check the how results differ and the values differ by the time that it's described in the data. So regarding choosing of NoSQL or the question, will SQL databases die eventually? No, because each database should be chosen according to requirements, to the needs and performance and such stuff. A lot of things should be taken into account. Don't choose the most popular or trendy database. So keep in mind that choose database should be done very wisely. And how to write a CV, kind of meme here. If you don't know SQL, you are expert in NoSQL. That's of course false. So maybe guys, you have any questions, Danila?
Yeah, there are two more questions. Guys, if you have any more, please post them to the chat. The first one, could you, nope, not this one. Please name examples of data and cases from real life where NoSQL is a good choice.
Okay, for example, we used white column database for data analytics because it provides the API and provides like saving of petabytes of data, and the analysis and querying of this data is fast. So in this case, white column databases will be useful for you. As I mentioned before, we have the Elasticsearch database, which is useful for data querying, for data search. In case, as I gave an example with texts, for example, in real life, we had an experience where we need to find the articles or text in articles. And as we had like more than 1,000 or 10,000 of articles, you cannot just use SQL here and write like operator, because the text is more complex, and we shouldn't use like while we using search in text, we cannot provide the pretty same symbol structures that was used in text. Sometimes it differs, and anyway we should find the text. In these cases, Elasticsearch is useful.
An example of full text search engine that everyone knows is just Google. It doesn't use Elasticsearch, it uses some internal, but basically it's a NoSQL database. You use it every day.
Yeah, good example. For example, of time series databases, we can check that as an example, loading of our systems, like at evenings we have
Any kind of metric, yeah.
This kind of metrics are very useful. You don't have to use, of course you can use SQL, but if this database is designed specifically for these cases, and if this is your case, feel free to use it. And as we mentioned in the first part, document-oriented databases, they are convenient in purpose of scaling. but don't forget that you can lose some consistency in your data. So if consistency is not the thing that is very important for you, for example, you are storing some information about, I don't know, cats and dogs, new posts and jokes, I don't think that consistency is the thing that you are worrying about. But bank guys who work with transactions and money and billions of dollars, I think they worry. So they should use SQL type exit databases.
Yeah, thank you. And probably the last question, if we cannot use joins in Redis, then how are we going to access many entities at a time? Here, I will answer. The answer is pretty simple. You don't. Redis is a very special database. It doesn't fit in many use cases. And if you need joins, if you need to access many entries at a time from the business perspective, then you don't use Redis, use SQL or Mongo. These are great databases. But if you don't need it, why not use Redis? Okay, guys, any more questions?
Let's wait
Yeah.
little bit.
I also wanted to say that there are more than 200, I think, production-ready NoSQL databases nowadays. Different cloud providers write their own databases like DynamoDB in AWS, Amazon Cloud, or Cosmos DB in Azure, Microsoft Cloud. So we covered the very basics. You should read the documentation of the database that you want to choose and see if it fits you. And yeah, we just couldn't cover all the possible databases. Okay, I don't see any more questions. I don't think that there are any. So thank you, Rodion, for a great presentation, and thanks, guys, for joining us today. See you next week, and I remind you about our Christmas event that will take place on the 27th of December, and you can submit your questions either in Slack or LinkedIn, or probably on the YouTube comments too. Thank you, guys.
Thanks, guys. Design databases properly. Bye.
Bye.